Today we will discuss about the logit model by maximum likelihood and connected to it the marginal effects at mean and goodness of fit and LR test. Now when the dependent variable is categorical, it is inappropriate to use the linear regression method. Okay, so in such a case we will discuss we use the logit or probit model. Now in this class I will discuss about the logit model. Okay, so it is one of the most versatile techniques in the class of generalized linear models. The function is the logit transformation, that is natural log of odds for some event to occur, and suppose that there is a random variable z which can take two values. One value is 1 which indicates success, another value is 0 which indicates failure. So the logistic distribution of that probability of success is equal to pi I equal to e to the power bi xi divided by 1 plus pi xi, where pi I is the probability of success for any given observation in the ith population. Xi is the vector of explanatory factors. Now we can therefore write 1 minus pi I equal to 1 divided by 1 plus e to the power bi xi, and from 1 and 2 we can have pi I divided by 1 minus pi I, that is odds ratio, is equal to e to the power bi xi. So log of odds ratio, that is log normal pi I divided by 1 minus pi I, therefore becomes equal to bi xi. So we can linearly transform the regression into a logistic regression model. So in case of k variable model we can write ln pi I divided by 1 minus pi I equal to summation of k equal to 0 to capital K bk xik, where I equal to 1 to n, and here we solve the problem by using the maximum likelihood estimation method. So I am not going to the detailed analysis. You can go through the slides and if you have any problem you can contact me. So I am directly going to the logistic regression method in STATA. So in STATA, for logistic regression we can use the here I am using the 68th round, the same data, wage data. Okay, so for that purpose we have to do certain preliminary steps. We have to go to certain preliminary steps. We have to convert the wage data into the employment data, and for that we will, and after that we will do the maximum likelihood estimation. Now here one such popular estimation method is two-step Heckman's procedure. You can remember in the earlier class I told you that we were actually deleting those observations for which wage total is equal to 0, and we were taking only the positive values of the wage total, but I mentioned that this is not a proper procedure. For the sake of simplicity I was doing that. This is not a proper procedure because for that if we do that our sample becomes biased. So the right procedure is to follow the Heckman's two-stage procedure. Now suppose that W star I equal to Z I gamma plus ui, where W star I is the difference between the market wage and the reservation wage. What is reservation wage? Reservation wage is the minimum wage for which any individual is prepared to work, and if the wage is less than that, then nobody is willing to work in the labor market. So that is the reservation wage. So we can observe a dichotomous variable, a value of 1 if a person enters into the labor market and 0 otherwise. That means if Wi equal to 1 if W star I is greater than 0, that is reservation wage is greater than 0, and if W star I is less than equal to 0, then WI equal to 0. Now to find out the reservation wage in our sample, we have to find out the minimum wage rate in our sample. So going through that, before going to that, we can observe that there are a large number of missing values in case of wage total, which is denoted by dot. So we have to first convert those missing values into 0, otherwise those will be taken as to be true, as I have mentioned earlier. So we are using the same data set and just replace wage total, replace wage total equal to 0 if wage total equal to dot. Now if we go through the values of the wage total variable here, I am not going to the details. We can find that the minimum level of wage is equal to 30 in our sample. So we can assume safely that 30 is our reservation wage. So if any wage is greater than 30, then everybody will participate the labor market, and if wage is equal to 30 or less than that, nobody will be willing to participate in the labor market. So we can convert the wage total equal to 0 if wage total equal to 30, and we can also convert wage total equal to 1 if wage total greater than 30, and all those other values, that is either it was 0 or it was missing values, that has already been converted into 0. So we can see that our wage total variable has been converted into a dichotomous variable, that is its value is either 0 or 1. To test that, we can use the tab command, tab wage total. As you can see, it has been converted into 0 or 1. Now we can rename the whole variable into a variable participation. So rename wage total space participation. So the name is changed and we have converted it into a dichotomous variable. Now we have to create certain dummy variables in order to do our regression. First of all, let us create the female dummy variable. We have the variable sex here. So tabulate sex, generate gender. This will create two variables, gender 1 and gender 2, and from if we go through the layout of the 68th round schedule 10, then we will see that code 1 is used for male and code 2 is used for female. So rename gender 2 female, and you can drop the gender 1 variable, or you can also keep it as you wish. So we have created the female dummy variable. Now we will create the religion dummies. Religion is denoted as household religion, HHD religion here. So tab HHD religion, comma, generate Jain religion. Here we can see that 8 variables have been created, and if we go through the schedule, then we can see that religion 1 is Hindu, religion 2 is Muslim, and all the other religions are not needed here. We will not use in our regression, so we can drop them. So rename religion 1 Hindu, rename religion 2 Muslim, and we can drop all the others, or you can keep them. That depends upon your choice, whatever you wish. So we have created the religion dummies. Now we will create ST, SC and OBC dummy. Okay, so household group is the variable which is denoting the social group. Household group religion, where is household group? Yes, this one. So tab household group, generate SOC, social group. So rename, as far as the codes are concerned, rename social 1 as ST, rename social 2 as SC, rename social 3 as OBC, and we can drop the remaining group, that is the upper castes. So SC, ST, OBC dummy variables are created. Now we will create the education dummies. So general education, Jain Edu, this one, tab Jain Edu, Here from the codes we will know that education 6 is primary, education 8 is secondary. So rename edu 6 primary, rename edu 8 as secondary. Then education 10 HS, rename edu 10 HS. Edu 11 is graduate, edu 12 is PG, so rename edu 11 graduate, rename edu 12 PG, and we can drop all the others. So drop So we have created all the education dummies required for our regression. Then we will create technical education dummy. Okay, tech edu. So tab tech edu generate tech. Here we are only interested into the persons which have no technical education. So tech 1 is the persons with no technical education. So rename tech 1 as no underscore tech, and we will drop all the others. So select them one by one. And drop them all. So we have created technical education dummy. Now let us create some interaction dummies. Suppose we are interested in female Hindus. Then female Hindu and female Muslim. So xi space I dot female star Hindu. Okay, so drop the first one and rename the second one as female Hindu. Once again, xi space I dot female star Muslim. Once again, drop the first one and rename the second one as female Muslim. Sorry, female. Okay. So we have created two religion dummies with interaction dummies with female Hindu and female Muslim. Now create female ST and female SC and female OBC. Okay, so xi space I dot female star ST. Drop first one, rename this as female ST. Again xi space I dot female star SC. Drop the first one, rename the second one as female SC. Again xi space I dot female star OBC. Drop the first one and rename the second one as female underscore OBC. So we have created all female caste dummies, and then female education dummy, female primary, female secondary, all of them. So xi space I dot female primary. Drop the first one and rename the second one as female primary. xi space I dot female star secondary. Drop the first one, rename the second one as female secondary. xi space I dot female star hs. Drop the first one and rename the second one as female underscore hs. xi space I dot female star graduate. Drop the first one and rename the second one as female underscore graduate. xi space I dot female star pg. Drop the first one and rename the second one as female underscore pg. So we have created all the general education dummies. Now female with no technical education dummy. xi space I dot female star no tech. Oh sorry, there is one space here. Now drop the first one, rename the second one as female no tech. We have created all the technical education dummies and general education dummies for the female. So all the creation of all the variables is completed. Now our labor market participation equation, that is logit equation, is log of odds ratio of the participation, that is ln wi divided by 1 minus wi equal to beta 1 plus beta 2 into household size. Now we assume that the household size is an important explanatory factor for probability of participation, because if the household size increases, then the pressure on the members is higher, then he will try to participate the labor market. So household size has impact on the probability of participation. Then we are taking the ordinary female dummy, then female Hindu interaction dummy, female Muslim dummy, then female ST dummy, female SC dummy, female OBC dummy, then female primary education, female secondary education, female HS, female graduate, female PG, and female no tech, and UI is the error term, stochastic error term. So our equation, our logit equation will be here. I have used the variable wage total, but actually our variable will be participation, because in our exercise we have already renamed it as participation. So participation is the variable this is the participation variable. This depends upon the household size, then go to the dummy variables, then female dummy, then taking all the interaction dummies, female Hindu, female Muslim, female ST, female SC, female whether we have taken female OBC, yes, we have taken female OBC, female primary, female secondary, female HS, female graduate, female PG, and then female no-take. So this is our logit equation and enter. So this will be our result. Okay, as you can see here also similar kind of result is shown. So let us explain the result. Now, probability of participation in the labor market is actually decreasing significantly if household size increases. Then if the participant is female, then we can see that there is no significant relation in the probability of participation. If the, here we can see that if the gender is female ST, so if the participant is female and ST, then probability of participation is actually increasing positively. Then if it is SC, here also it increases positively significant, positive and significant. Primary, if the female participant has primary level of education, then it has the probability of participation decreases, but when it is the educational level is in, and then also in case of secondary and HS also we can see that negative probability, that means probability decreases. However, in case of secondary and HS, there is no significant relationship between the probability of participation and the participant. But if the female has the graduate level of education, then probability of participation increases significantly. If the female participant has post-graduation level of education, then probability increases more. But if the female has no technical education, there is no significant relationship between the probability of participation and the probability of there is no significant relationship with the variable with the female participant with no technical education and her probability of participation in the job market. Now, in case of logit model, we are not in the position to directly predict the amount of marginal effect, because the estimated coefficients are not the marginal effects, as in case of OLS. Here we have the multiplicative effects. Fortunately, we can transform them into marginal effects. That means in case of linear regression, we can see that suppose y is equal to a plus b into x. So here if x increases by 1 unit, y increases by b unit. So dy dx is equal to b. That is a marginal effect. But in case of logit model, the dependent variable is not y. It is actually pi I divided by log of pi I divided by 1 minus pi I. So we cannot say that b is the marginal effect here. So we have to convert the coefficients into the marginal effects with some extra exercise. So marginal effect, to find out the marginal effects, we are using the command margins comma dy dx within bracket star at means. This is the command of marginal effects. So it is a must to find out the marginal effects in case of logit or probit regression, because the value of these coefficients do not signify anything. There is no numerical value of these coefficients. Only the signs are relevant. That is, whether seeing the coefficients, signs of the coefficients, whether it is positive or negative, you can say that whether the probability of participation increases or decreases, you can at most say that. Otherwise, the values of these coefficients do not signify anything. To find out the significant values, we have to construct the marginal effects. So, margins comma space dy dx within bracket star bracket close space at means. This is our command, and this will now all these things are, as we can see that it is written as dy dx. So these are the marginal effects. Now how much? Now if household size increases by 1, probability of participation in the job market decreases significantly by minus 0.015 approximately. So in this way you can explain the marginal effects in case of logit model. So we have to construct the marginal effects separately. And at means, what does that mean? Means that if we consider the values of all the others, if we suppose in this case, if we consider the values of all the others explanatory variables remain at their mean levels, then when household size increases by 1 unit, probability of participation in the labor market decreases by 0.015 units approximately. So we are assuming that in this case the values of all the other variables remain at their mean values, and mean values are given here. So at means denote this explanation. So this is the marginal effect of the logit model. So we can also find out the marginal effects by the by some special operations which are given here, but that is extra, that is not needed for you. If you learn this one, that is sufficient. So now we go to the goodness of fit. When we build the logistic regression model, we assume that the logit of the outcome variable is a linear combination of the independent variables. Now this involves two aspects, as we are dealing with the two sides of our logistic regression equation. First, consider the link function. Okay, here the logit function, link function of the outcome variable on the left hand side of the equation. Here we are assuming that the link function is logit function or logistic regression, that's why is the correct function to use. That is, we will test whether we are using the correct link function, whether the logistic regression is the perfect regression, whether logit is the correct function, that we will test. And secondly, on the right hand side of the equation, we assume that we have included all the relevant variables. That is, we have not included any variable that should not be in the model, and we have also we have not excluded any variable that should be within the model. So it could happen that logit function as the link function is not correct choice, or the relationship between the logit of outcome variable and the independent variables is not linear. In either case we have a specific error. So specification error. So misspecification of the link function is usually not too severe, because whether the logit or probit, we are actually we will arrive almost the similar kind of result. So in the STATA we are actually using the we will actually use the command link test to detect the specification error, and it is issued after the logit, that is, it is post estimation command. It is used after the logit function is done. So the link test, the idea behind link test is that whether this model is properly specified. That is, one should not be able to find any additional predictor that is significant except by chance. So we will use the model, we will use the command link test. Link test will give us two values. One is hat and another is hat square. Hat is the predicted value and hat square is the square of the predicted value. Now the variable hat is, the hat should be a significant predictor, since it is the predicted value of the model. This will be the case unless the model is completely misspecified. If the model is misspecified, then the result will show that the variable hat has p-value which is insignificant. And on the other hand, if our model is properly specified, then hat square should not have much predictive power except by chance. That is, if hat square is significant, then link test is significant, and we have omitted some relevant variables in our function. So as in most of the cases, the hat square will come as significant, because we have only used a few variables, and there are large number of explanatory variables that we have not incorporated in our model. So that is not too much important for us right now. We will actually see whether our hat variable has the p-value which is close to 0 or 0. So our command is link test comma no log. Our command is link test no log. As we can see that our hat variable has p-value which is 0, so therefore our model is perfectly specified, our predicted value is significant. However, our hat square variable has also coefficient has also p-value with 0 value. That means we have omitted some significant variables which could have been incorporated, but as we know that we have selected only a few variables in our analysis, so there is no such serious error in this case if we have such a result. So this is our whole analysis of the logit model, and so this is the link test, is the last test which we will use in our logistic regression model. Now let us discuss about the result a bit. So we will discuss about two things. One is likelihood ratio chi-square and another is pseudo r-square for this model. Let us see the result. Likelihood ratio chi-square. This is the likelihood ratio chi-square and this is the pseudo r-square. What do they mean? The likelihood ratio chi-square is an omnibus test to see if the model as a whole is statistically significant. It is 2 times the difference between the log likelihood of the current model and the log likelihood of the intercept only model. And which are these? These are log likelihood of the current model, and log likelihood of the intercept only model is this log likelihood of the current model is the last one, and intercept only model is the first one. So this is the twice of the difference between them. So if the p value of the likelihood ratio chi-square is 0 or close to 0, here we can see that p value is 0, then our model is significant. So that means, and then pseudo r square is slightly different thing. It is the proportion of change in terms of likelihood. It is a pseudo r square because it is unlike the r square found in the OLS regression, where r square measures the proportion of variance explained by the model. Pseudo r square is not measured in terms of variance, since it is the logistic regression, and in logistic regression the variance is fixed, as variance is the standard variance of the standard logistic regression, because the value varies from 0 to 1, that's why. So it is a proportion in terms of log likelihood. So this is also an important concept. So this ends our discussion about the logistic regression. Now one task is pending right now, which is we have not created any log file in the beginning. So how can we, in such a case, if you forget to create the log file, how do you save your work? As we can see that we can open a notepad. We can open a notepad in such a case. Open a notepad and then select the whole exercise in the result window, then copy them and paste them in this new notepad. As you can see that they can easily be pasted. So just save this notepad as log, whatever name you can give. I am giving log logit model. So this is the logit model log file. Since I had forgotten the task of opening the log file in the beginning, I am saving it in the notepad. Otherwise, before beginning, you just open one log file. Both of the exercises will give you the same result. Now we have actually changed a certain number of variables from our wage data. So to preserve our wage data as it was and to create the new data, we just saving is at save as participation. Now this is the new file participation, and when we do in this way, our old wage data is remains intact, and in addition we are creating one new participation file here. So this completes our exercise. If you have any question, you can freely contact me in WhatsApp when you wish. Thank you.